Hey there folks, Meteorologist Hunter McCullough here for Northern News Now Plus and another episode of Beyond the Forecast. Today we're going to be talking about another item that we talk about pretty often on air, but we don't have enough time to delve into exactly what it is and what it means and what it goes into the forecast when we make a snowfall forecast, and that is snow to liquid ratio. So this episode is going to go more in depth about the snow to liquid ratio, how we find it, what it means, and what it means for forecasting when it comes to snowfall totals. Without further ado, here you go. Hey there folks, Meteorologist Hunter McCullough here for Northern News Now Plus and Beyond the Forecast. I'm going to talk to you about a topic that we've talked about a little bit before, and we've touched on this just a tad. I want to go more in depth on this, and this is snow to liquid ratios, and talking about how the moisture in our atmosphere and temperature interact with each other to produce the amount of snowfall that we do see. So first off, what is a snow to liquid ratio? Well, we first have to talk about precipitable water, which what that is basically this column from the surface all the way to the top of the atmosphere. The amount of water in that column, if it were able to become rain and rain out, that is our precipitable water. That is how much moisture is basically available for that rain or snow to develop here. And so taking that, we can kind of measure a little bit about just how much snow we could be getting. This is what models take into account. This is what meteorologists take into account when making a snowfall forecast. Temperature has a huge role in just how much snow we're going to be getting with the amount of water available in our atmosphere. So on average, we usually see less than an inch of water above our heads in the winter when it comes to a snowstorm. But usually we use this as the ratio. 1 inch of water in our atmosphere here. How much is that going to produce with these three different temperatures? The higher the temperature, which it can be above freezing at the surface, as long as it's below freezing above our heads. 30 degrees and then 18 degrees. So the warmer the temperature, the lower the ratio is going to be. And again, it's just a ratio, literally. So usually around 32, 33, 34 degrees, it's about a 4-to-1 ratio, meaning 4 inches of snow for 1 inch of precipitable water above our heads. Around 30 degrees, this is our average. We usually typically see 10-to-1. 10 inches of snow for every 1 inch of precipitable water above our heads. That is our average. That's what most models also use as the average. So we have to also look at temperature when we're looking at these models and see that, well, it's actually going to be a little bit colder. This model's going a 10-to-1 ratio, so we have to actually increase that a little bit. Because if you get down to, say, 18 degrees as your ambient temperature outside, you get quite a bit more snow with the same amount of liquid moisture here. Dry snow, of course. This is the blowing snow. This is the very light, fluffy stuff. 20-to-1 ratio. This is the heavier, wet snow. You've got more moisture in that snow, and a little bit drier again the colder that you do go. We can literally see this in examples, of course, and this happened earlier this last year. It actually happened just a couple of months ago. So look at the date. You got right around Thanksgiving, as a matter of fact, November 26th, November 29th, 2025. I want to point out the amount of precipitation is basically the same. So again, you get the snow and then you melt it down, and that's what you get for your precipitation. That's how the National Weather Service measures the amount of precipitation that came from a snowfall. They literally just melt down the snow and they measure the precipitation. So I want to point out that it's almost exactly the same, but our snow totals are pretty different by about 2 inches. We got 2 inches more here. Why would that be? Well, that is because of our temperature. Look at this. Our actual high temperature was 26 degrees, a little bit warmer. Our actual high temperature on the 29th was 20 degrees, colder by about 6 degrees. So that difference in temperature caused our snowfall to be that much more here, 2 inches on the 29th, and just a little bit less than that here on the 26th. 3.2 inches, 5.3 inches with the same amount of precipitable water. And to calculate the ratio, you literally just divide the amount of snow you got by the amount of liquid precipitation that you got. And if you want to do this at home, you sure can. You got your snow measurement, of course. You just take a ruler or whatever, measure your snow. You melt that down, and then you measure the liquid, and then you just divide the two. So this was November 26th, was a 1 to 12 about ratio throughout that system, which gave us 3.2 inches. Meaning, again, if you had 1 inch of precipitable water, you would have had 12 inches of snowfall. So we had less than that. We had about 1/4 of an inch. And so we got 3 inches. With November 29th, we had a little bit more here, a 1 to 20 ratio, kind of that, almost that sweet spot. So 5.3 inches of snow divided by 0.26 inches of precipitable water here, and we got a 1 to 20 ratio, again, meaning 1 inch of water to 20 inches of snow. So temperature plays a huge role in the amount of snow that we get and the efficiency of the amount of liquid that we have available to us in our atmosphere. The problem is there is a certain point that it actually becomes less and less. And so what you need to understand, of course, this is another concept that we try to hammer home in meteorology, is that the warmer the temperature, the more capacity for moisture you have in the atmosphere. That's why it's so hot and humid when it's 80 or 90 degrees outside, because there's more capacity for moisture. If you have a ton of moisture in the region, you're going to be hot and humid. When it's cold outside, though, you don't have that much capacity for moisture. So the colder it gets, the less amount of moisture you're going to have. So this is a little example of a little graph here. The temperature, let's say it's around 32 degrees. So the temperature's high. You can have the most amount of precipitable water that you can have in the winter, but your snow total is still going to be relatively low, even though sometimes you can get high snowfalls because you have so much precipitable water. So let's say you have, 4 to 1 ratio. Well, if you have more than 1 inch of water above your heads, you still can get 6 or 7 inches of snow. It's going to be the wet and heavy gross stuff, but you can get quite a bit of snow still from this kind of scenario. As the temperature goes down, your snow total is going to go up, but also notice that your precipitable water is going to go down as well, the capacity for the amount of precipitable water that you have. So there's kind of a sweet spot where they meet to where you've got the correct temperature, the correct amount of precipitable water, and the correct amount of snowfall. And then eventually, as the temperature continues to fall, well, you're not going to have as much precipitable water, and your snow total is actually going to fall too. Can it be too cold to snow? It really can be. If it's way too cold to form any kind of clouds or to even start it's called the dendritic growth process, you can be too cold for that. So you can get some light snowfall and not really expect to see any kind of actual accumulation. So that kind of continues to go down. As the temperature goes down, the amount of capacity we have for moisture goes down, and eventually the snow total goes down. So what is the sweet spot? From my experience here, as a meteorologist, temperatures in the mid to upper teens is your ideal temperature if you want to see the most amount of snow. Roughly a snow to liquid ratio of 15 to 1 to 25 to 1. We have had snow to liquid ratios higher than that, however. I believe it was last year, there was a snow system that came through, kind of surprised us all the meteorologists around the region, and it ended up bringing us quite a bit more snow than what the models were forecasting, what we thought was going to happen. And it turned out that it was like a 65 to 1 ratio, something like that. And we got like 4 or 5 inches of snow just by a little bit of precipitable water, and that's because the snow to liquid ratio was so high, like 65 inches of snow to 1 inch of liquid water equivalent. And so we didn't have a ton of moisture in the atmosphere, but it was enough to cause a ton of snow to fall. We probably got like 4 or 5 inches. We were supposed to get maybe half an inch or something like that. And so, again, temperature plays a huge role in this. But if you want a big snowstorm, you want to probably see these temperatures into the teens to low 20s is generally what we want to see. And once we get to the single digits, it starts to get a little bit too cold for the amount of moisture that we have in the atmosphere. So there you go, a little lesson there on snow to liquid ratios and just how we use that to forecast here around the Northland when it comes to winter, when it comes to snowfall. Temperature and the amount of moisture in our atmosphere, again, play a huge role in what goes into making a snowfall forecast. Have a great day.